Nice launch trajectory and countdown net. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Welcome to our live launch coverage of the RRT-1 mission. Falcon 9 is currently awaiting liftoff at 7:51 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Hey everyone, my name is Soumya Srivastava, and I'm a structures engineer here at SpaceX. Today's mission will be SpaceX's 421st overall launch and the 126th Falcon launch of 2024. It will also be the fourth flight for the first stage booster that is supporting today's mission, which previously launched NASA's Crew 9 and 2 Starlink missions. After separation of the first and second stages, the booster for today's mission will once again head back to Earth, this time targeting a landing on our drone ship, a Shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. It's worth noting that, at our customer's request, we'll be ending today's webcast before payload deployment and just after booster landing. So at T-minus 7 minutes and 32 seconds, we're looking really good for an on-time liftoff. The vehicle is healthy, the range is ready to support, and the weather is holding steady, with a 60% possibility of weather-related launch constraints. While we wait, let's meet the vehicle that will be taking RRT-1 to orbit today. Falcon 9 is a 2-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. It's also the first and currently the only orbital class rocket that is capable of reflight. The 2-stage Falcon 9 vehicle on your screen stands 229 feet tall, and when it's fully fueled, it'll hold just over 1 million pounds of propellant. And we began loading those propellants onto both stages of the vehicle at T-minus 35 minutes. Starting from the top of the rocket is the payload fairing, which is a protective shell that encases the payload or satellite that's being sent to space. The fairings are made of a carbon composite material and have a 17-foot diameter, which encapsulates enough space to accommodate an average-sized fire truck. The fairing, made up of 2 halves, will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. Both of the fairing halves supporting today's mission are flight-proven and are flying for their second time. Once jettisoned, those fairing halves will fall back to Earth and splash down in the Atlantic Ocean, where they will be recovered by our fairing recovery ship, Doug. The second stage is powered by a single Merlin vacuum engine, or MVac engine, which is optimized to perform in the vacuum of space. After stage separation, the MVac engine will ignite and carry the payload to its final orbit. The second stage is connected to Falcon 9's first stage by the black composite inner stage, which houses the MVac engine and the system that decouples the 2 stages during stage separation. Below that is the first stage, which is powered by 9 Merlin engines. These 9 Merlin engines provide the initial thrust to lift Falcon 9 off the ground through the lower, thicker part of the atmosphere. There are 8 engines arranged around one center engine and are collectively held in place by a structure called the octaweb. Each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. Shortly after liftoff, the 2 stages of Falcon will separate. Stage 2 will continue to take the payload to its desired orbit, and Stage 1...
Falcon 9 tanks are pressing for strongback retract.
And Stage 1, which is also known as the booster, will return to Earth for recovery and reuse on a future mission using a combination of the Merlin sea level engines and the 4 titanium grid fins that are located near the top of the booster, which will guide the vehicle during its re-entry and landing. The Falcon 9 first stage is also equipped with 4 landing legs that deploy just before landing and allow for vertical touchdown on a drone ship or a landing pad.
Strongback retract has started.
We just heard that the strongback is beginning to retract. So at liftoff, the transport director will retract in order to clear the way for Falcon 9's ascent. And to prepare for that retraction, we'll see the clamps open around the second stage, and the TE will pull away in just a little bit from the rocket. So those are the clamp arms pulling away from the rocket, and then the strong back will begin to pull away from the vehicle. So at this point in the countdown, both the first and second stages are almost fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. The first stage and second stage should finish loading propellant about a minute apart from each other. The first stage finishing up at T-minus 3 minutes in a few seconds from now, and the second stage at T-minus 2 minutes. The white clouds you see around the vehicle are formed as the chilled gas above the LOX tank liquid surface vents overboard to maintain pressure in the tank as needed. And when the gas comes out into the warmer Floridian air, it condenses the water in the air and forms those clouds that you are seeing on your screen. After the second stage is fully loaded, we will come up on...
Stage 1 LOX load is complete.
So we just heard the call out for Stage 1 LOX load completion, and Stage 2, we will be hearing the call out for that one in just a little bit. And at T-minus 60 seconds, Falcon 9 will be in startup, and that means that the rocket's autonomous internal flight computers will have taken over the launch countdown. And after that, just inside of T-minus 2 seconds, we will light the Merlin 1D engines for liftoff.
Stage 2 LOX load is complete.
And we just heard a good call out there. The payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. So at T-minus 1 minute and 45 seconds to liftoff, let's listen in as we hear the series of callouts that lead up to launch.
Ground gas closeouts.
That white cloud from venting the TE LOX line is completely normal.
Falcon 9 is in startup.
Good callouts and indicating that Falcon 9 is now operating on its internal flight computers.
Go for launch.
So at T-minus 42 seconds, all systems are go for the launch of today's mission. Let's sit back and watch.
T-minus 30 seconds. -15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power and liftoff. Go SpaceX, go Falcon, go RRT-1.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. During ascent, we tilt or gimbal the engines, and that turns the rocket horizontally in a maneuver known as a gravity turn. We're still going up, but now we're also heading horizontally away from the launch pad. Moments ago, we throttled
Power and telemetry nominal.
Good call out there. Moments ago, we throttled the engines down on the first stage in preparation for max Q, or maximum aerodynamic pressure.
Falcon is supersonic.
Falcon 9 is now supersonic. Max Q is a critical moment during flight because the combined stresses caused by Falcon 9 accelerating through the atmosphere and the ambient static pressure are at their greatest.
Max Q.
And we are now at max Q, and the rocket typically needs to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit. You can track our progress to orbit by keeping an eye on the Stage 1 telemetry in the bottom corner of your screen.
Evac shell started.
Now we have several events coming up in quick succession: main engine cutoff, or MECO, stage separation, second engine start 1, or SES1, and fairing separation. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, which is where the first stage separates from the second stage. Followed by this, the MVAC engine on the second stage will light, which is called out as second engine start 1, or SES1. This engine burn, lasting several minutes, will propel the second stage and the payload to orbit. And in addition to these 3 major events, the fairing halves will separate shortly after SES1, so keep an eye out for all of those events coming up in just a few seconds.
Main engine cutoff. Stage separation confirmed. MVAC ignition.
And there you heard and maybe just even saw those events that happened back to back, which again were MECO, Stage Sep, and SES1. And just as a reminder, we will not have any Stage 2 views today following stage separation, and the remainder of our webcast will follow the Falcon booster returning to Earth. Next up will be fairing separation, about 10 seconds.
Fairing separation confirmed.
Good call out there for confirmation of fairing separation. And as I mentioned earlier, we will be attempting to retrieve these fairing halves again today using our recovery vessel Doug once they fall back to Earth. It's about T plus 4 minutes and 3 seconds into today's mission. At the T plus 6 minute and 12 second mark, we expect to have some great views of the first stage entry burn. And for the entry burn, we relight 3 of the M1D engines on the first stage, starting with the center E9 engine, followed shortly after by the E1 and E5 engines. This helps slow down the vehicle as it passes back into Earth's denser lower atmosphere. We need to slow it down to reduce re-entry forces, which ultimately helps us recover and reuse the first stage. During the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but we're still moving really fast. And this causes the vehicle to fly through Merlin's exhaust gases, or its plume, and this deposits a layer of soot on the vehicle surface, which is why our vehicles look the way they do. That soot comes from the carbon-based fuel that Falcon 9 uses. On second thought, we might not have great views of entry burn, but hopefully we do. Reusability is key to lowering the cost of spaceflight, which enables more investment in critical scientific research. The Falcon 9 first stage that is supporting today's mission is flying for its 4th time. And while this booster is on its 4th trip to and from space, we're working towards qualifying our fleet of Falcon boosters and fairings to support 40 missions each.
Stage 1 entry burn startup.
Stage 1 FTS has safed.
And there you can see the entry bird. I'm glad we had a great view.
Stage 1 entry burn shutdown.
Good call out there for the end of entry burn. As you can see on your screen, the telemetry on the bottom left-hand corner indicates that the first stage is slowing down. Next up, in about a minute, we will have the landing burn. The Merlin engines on the Falcon first stage are optimized for sea level, and these achieve about 190,000 pounds of thrust during ascent and entry. And while it won't be visible on this webcast, the single MVAC engine on the second stage has a much wider nozzle and is optimized to operate in space, producing 220,500 pounds of thrust in vacuum.
Stage 2.
Transonic.
Stage 2 is internal guidance.
Good callouts there for stage 2. So coming up in under 30 seconds, we will have the landing burn of the first stage. And the landing burn is the final burn of the Falcon 9 booster that is used to reduce the remaining speed of the vehicle in order to allow for a soft...
Stage 2 FTS is safed.
In order to allow for a soft touchdown on the drone ship.
MVAC shutdown.
Stage 1 landing leg deploy.
Great view of our drone ship, a Shortfall
Nominal
of
park
Gravitas.
orbit insertion.
And there you saw and heard
Stage 1 landing confirmed.
and saw the successful landing of our Falcon 9 rocket. This mission marks SpaceX's 126th successful Falcon launch of 2024, and the booster's landing marks SpaceX's 383rd recovery of an orbital class rocket. As a reminder, this was the 4th launch and landing for this first stage. And as I mentioned at the top of the show, we'll be ending today's live coverage before payload deployment. So with a successful booster landing, that wraps up our coverage for this mission. All of us here at SpaceX would like to thank our customer for entrusting us with today's mission. And we also want to thank the Eastern Range and Federal Aviation Administration for supporting today's launch. And thank all of you for your support and for tuning into today's mission. Remember to follow @SpaceX on X for launch updates, and we'll see you here again very soon.